right, before we get started, I have a couple of quick questions. How many people are Java developers in this room? Okay. All right, how many people code in JavaScript? Okay, Python? I don't know. Erlang? Nobody? Okay, oh, one person. Okay, that's nice. All right, so this session is a little bit general purpose for the most part. Some of the tools that I'm going to show at the end are basically Java tools, but you can find, if you're not a Java developer, for example, if you code in Python or JavaScript or something else, you can find similar tools in all those different ecosystems, okay? So let's get started. My name is Patrik Patel. You may have read one of the books I've written. The most important thing on this slide is my handle here. This is where you can reach me on LinkedIn, X, and Blue Sky. So if you have any questions after this, please let me know, and happy to follow up with you on any of those platforms, okay? And I work for a company called Azul Systems, and we specialize in the Java space. We make Java virtual machines. That's all we do. The most downloaded build after OpenJDK is our Azul Zulu build, which is an open source version of OpenJDK. It's completely free and will always be free. And we have a high performance JVM. And if you're a Java developer, we have a newer tool called Code Inventory, which allows you to find dead code and unused code in your application so you can reduce your technical debt. So we'll talk a little bit more about this, but this is not a product pitch. This is more a general conversation about software architecture and quality and things like that, okay? So I have another question for you. How many people in this room are software architects? Anybody? Okay. So there's always a few people who are software architects. Now, one of the main questions that I see when I give this presentation is, are software architects also programmers, right? So let's talk about that for a few minutes to figure out where the line is between someone who is just a software developer and someone who's an architect, okay? So one of the main things about being a software architect is the role that you play at your company is heavily dependent on what your company does. So a lot of software architects at smaller companies will also be software developers. At bigger companies, software architects just do software architecture or other things. So let's dive into that a little bit to understand about this, right? And again, it also depends on the role that you have at your company. A lot of places, you'll have someone who's a senior or principal software developer, but they also play the role of a software architect because it's a small company and there's not a big dev team and stuff like that, right? So, and finally, it also depends on you. I know a lot of people who are software architects that they only like to do software architecture and they let other people on their team do more of the coding and some of the other DevOps and other types of roles, right? So there's three main things that kind of depend, that will depend on like what your role is, which company you work for, and other things like that, right? So let's define what a software architect does first, and then we'll kind of dive into more of the code quality and other things in a few minutes. So when we think of software architecture tasks, and how many people in here, again, were software architects, right? There were a few people in here that were software architects. So a lot of this software architecture is around system design and architecture. That makes sense, right? But one of the things that I did as a software architect, I worked as a software architect for almost 7 or 8 years before I left to do a startup. And I spent actually a fair amount of time doing the second bullet on this slide, which is technology selection. That could be everything from picking a library to, are we going to use Kubernetes, right? So there's a lot of, it's quite a broad umbrella. And I actually spent most of my time doing the last bullet on this slide, which was working on high-level performance concerns, high-level and low-level. So I led the performance engineering team at a large telecommunications company in the US called AT&T. You may have heard of it. But I was the software architect for performance across the entire platform. We ran about 1,000 different app servers in production across a giant database and all that kind of stuff. So it was a really, really big application. And so that's where a lot of this presentation comes from, is from the experience from that, right? So along with that, some other software architecture tasks include setting internal guidelines and best practices. So we would come out with best practices that the team had to follow, all the way down to the coding level and the process level in terms of software development. And then probably the two most important things are collaboration and leadership that a software architect provides. Again, this depends on which company you work for. And one thing I will say is that a lot of people think that their career progression should be, okay, you start off as a junior developer, and then you become, mid developer, senior developer, principal developer, and then where do you go from there, right? And so a lot of people think software architecture is the right way to go. Some people think, okay, maybe I'll go into management. But this is something that you have to think about carefully, because the joke I make here is like, how many people do you know who are managers for a dev team were really good developers, but not really good software managers or team managers, right? That there's a big jump in terms of how you do those two different tasks or those two different roles. Not all software developers who are good will make good managers, and vice versa, of course. And same thing for architects. Architects have to think of lots of different things. So, we talked about just a few of these, 6 of these specific things that as a software architect you have to consider and think about. But if you're really good at software development and writing code and working down in the guts of a system, is being a software architect right for you? It might be, but it may not be. So it's something to think about at least, okay? So, one of the key questions that we want to try to talk about here, because we're talking about software architecture and code quality, is how removed should a software architect be from coding? Now, of course, the answer to this question is it depends. It depends on the 3 things we talked about previously, which is what's your role at the company, what company are you at, and also depends on you and what your skill might be, right? And again, it's a spectrum. A lot of software architects code frequently, some don't code at all, right? But there's some reasons why a software architect should be also a software developer or a coder at least, right? Understand code at the low level. One of those is maintaining technical proficiency and credibility. So if you're a software architect and you don't understand how code works, then that could be a problem, because then how are you supposed to talk to software developers and understand all the concerns that they may have, right? Now, along with this is, if you don't understand some of the low-level code, how can you also keep up, right? So for example, in the Java universe, we recently introduced, I think in Java 17, something called records came in. Now, if you don't understand what records are and what DTO is and what data-oriented programming is, how can you talk about this to your software developers? So maintaining a level of technical proficiency is extremely important. Being able to talk to developers and understand the low-level implementation challenges. And that's the second bullet on this slide, is being able to understand both low-level and high-level technical challenges so that you can design systems. And what are the trade-offs that come along with this? Now, there's a prominent speaker called Neil Ford who talks, basically all he does is talk about software architecture. And one of the things that he says that I really like is that software architecture is a series of trade-offs. You're always trading off something when you make a decision, right? So if you go, for example, to Kubernetes to build microservices as opposed to a monolith, what's the big trade-off that you're making there? The trade-off that you're making is that you're adding a lot of complexity and a lot of latency in your system by going to this microservice, distributed compute type of environment as opposed to a monolith, which is simpler in a lot of ways, right? If you keep up with what's happening in that area right now, there's this term called modular monoliths, which is kind of gaining some traction right now. So we're kind of going back to, okay, we don't need everything to be a microservice. Maybe something should be a monolith because it's just faster and it's a better fit for the type of system that we're building, okay? So let's move on and talk about why software architects should not be software developers or should not be involved in coding, okay? So one of the top things is that as a software architect, there's a lot of different things you have to do. Do you have time to do all those different things, right? Do you also have time to go and be a software developer and make a meaningful contribution to the actual coding part or the software development process, right? So that's kind of a big thing to consider about this, right? And also, the last 2 bullets are quite important here, is that if you're also a software developer and you don't rely on the people on your team, senior developers, principal developers, are you also introducing bias? So, we talked about, for example, in Java, there's a new thing called records that came out. Data-oriented programming is something that's coming up. If you don't understand this and you don't know what all the nuances about this are, you may have some bias and say, well, we shouldn't use records. We've always used standard Java objects to code. So maybe it's not a good thing, but almost everyone in the industry agrees that moving to records is a good thing for performance and simplicity and code management types of things, right? So you introduce that personal potential bias instead of relying on the smart people on your team to tell you what the right path forward is in terms of moving your application or your platform forward, okay? So, a couple of quick things and then we'll shift gears. It's essential for software architects to maintain a strong understanding of coding principles and practices regardless of whether they code actively or not. Okay, so we've already talked about this, but I just want to make this point one more time. And also the level of coding should be tailored to the specific context of the project and the architect's role. Again, we've talked about this already, but I just want to summarize the last few slides in these few words. Okay, and also, we talked about communication and collaboration. Communication and collaboration between architects and developers are critical for ensuring that decisions are aligned with implementation realities. So what this means is that if you're an architect, if you play with the role of an architect or if you move into an architecture role, if you're so disconnected from what the developers are doing or what the implementation needs to do and all those different things, then you have a problem because you're no longer connected with what actually needs to happen. You make decisions in a vacuum, as we say. Okay? So let's get into some extra topics here. Talk about architecture and code, some processes, and let's quickly look at tools. So we have about 30 minutes to do this. Should be enough time. Okay? So how do software architecture patterns help produce better software and code? Right, so this is a question that's been asked forever, but let's dive into this and think about what some of the different things are, right? So this is a pretty busy slide, so we'll walk through it very quickly, okay? So the first thing is that as a software architect, when it comes to code and code quality, you're the one who has to provide the leadership and the guidance for creating a solid foundation for your code, right? You also have to make decisions along with your dev team for managing complexity and long-term maintenance, because this is one of the biggest problems that people have, development teams have, is that you accrue technical debt over time. What do you do with this technical debt? A lot of times the answer is you just park the old system and rebuild everything from scratch. But that's extremely expensive and very complicated and has a lot of risk associated with it, especially nowadays, because 5 or 10 years from now, the system you're designing, the people who built it may no longer be at your company. They may have moved on. So someone who built this part of the system that has a lot of business logic in it, they're no longer there. So can you really throw your code away and rebuild everything? Right? Is that possible to even do? Okay. And then the last thing here is we have scale, team, and performance. Okay. So let's talk about each one of these quickly. The solid foundation part is essential for keeping all the developers on the same page and creating like almost a human knowledge base now. Right? So I know the last presentation of the keynote here was on artificial intelligence. So one of the things that I've started doing, I don't play the role of a software architect now, but I know some friends who are doing this, which is they take all of the stuff that they work on as a software architect and they use something like Notebook LM. Has anybody heard of Notebook LM from Google? Right, so a few people. If you haven't heard of this, it's an incredibly useful tool. I believe it's still free. Is it still free to use? Yeah, it's still free to use. I have like a Google Plus or Gemini Plus account, so it's included. But anyways, it's a wonderful tool. Basically, what you do is you feed it documents, and you say, this is my notebook. So I take all the stuff from my team, even though I'm not an architect, and I put in like our policies, I put in other kind of information that I've collected, and they can just go to this Notebook LM that I share with them. And again, you can do this as a software architect. You can put in your software architecture diagrams, you can put in your system design documents, and then the people on your team, and even me, can go in and say, oh, what's the best way to connect to this specific microservice, for example? Or, what's our standard coding practice around DTO objects? And then it will respond and say, the latest thing to use is records, don't use this old way of doing it, et cetera. So it's a way to compile everything. And on the slide here, I say that, again, it's a human, the software architect is a human knowledge base, but what you can do is you can offload the human part of it and put it into AI nowadays using something like Notebook LM. It's an incredibly useful tool. If you don't get anything else out of this session, hopefully that's the one thing that will really help you, because you can literally throw loads of documents at it. You can even take a YouTube video and paste the URL into there, and it will include the YouTube video's transcript as part of a result, for example. So it's a really useful tool. It's called Notebook LM. Okay? So let's move to the middle topic here, which is managing complexity in code. So as one of the things that I did as a software architect, even though I was focused on performance, is I very heavily focused on legacy code and removal of legacy code and trying to write things or make sure that developers wrote things with less bugs. Obviously, everyone wants less bugs, but how do you do this, right? So if you have coding practices as a software architect, if you're involved with that kind of stuff, it can help keep from introducing less bugs. And one of the things I always stressed as an architect, especially when we did code reviews with my team, was we spent a lot of time talking about low and high level reuse. Basically, how do you do composition? We favored composition over inheritance, for example. We tried to have a high cohesion but low coupling, right? Loose coupling but high cohesion. So these are things that as a software architect, I tried to enforce during code reviews. Okay, so the last one is pretty easy to understand. If you're a successful architect and if the rest of the team is on board with your vision, one of the things that can also happen here is that you can also have more velocity across your entire team. So we've all heard of like the 10x developer, right? So nowadays we don't think in terms of the 10x developer because that's kind of passé. It doesn't really make sense. But what we think more about is the 10x team. How can a team work faster together with multiple people on it? So as a software architect, you have the capability of influencing a team so that they're able to deploy faster, build more features, and have more people on the team because there's more communication and collaboration on that team. Okay? So we've already talked about this, but we'll run over them very quickly. If we can have more developers, again, solid foundation for code as a software architect. If you're able to provide proper documentation and guidance and vision around this, you can have more developers working on the same tech stack. Everyone has knowledge of the overall system and design, so a developer doesn't go off and write something in a way that has to be refactored later, so you save time doing that. And also you have proven patterns. This is how everyone is supposed to use this kind of pattern for building certain kinds of code, or even at the systems level, right? Everyone has to write microservices, they have to follow this kind of interface, those kinds of things, okay? So managing complexity, a good architect helps to lead in ways that provide lower bugs in code. We get better low-level code reuse and high-level component reuse, okay? And then we're able to scale a team because better code quality means faster releases. Better code quality also means people can work on the same code, and we get high-level code reuse, okay? So let's move swiftly on and talk about processes for a bit. Now, should software architect get involved with something? Everyone does code reviews. Does anyone not do code reviews here? Okay, everyone does code. Oh, you don't do code reviews. Okay, you don't, or you do code reviews? Oh, you do. Okay, just making sure. So, should a software architect get involved with code reviews, right? And of course, the answer to that is depends. But for me, I like to get involved in code reviews because that was part of what I tried to do as a performance, because performance was my primary responsibility. I needed to make sure that people wrote code in a way that was mostly efficient, right? So if you work in the Java universe, you know that the JIT, which is inside the JVM, optimizes your code for you. So you don't have to obsess about having low-level optimizations in code. The JIT will optimize that code for you. But one of the key things that I had to do is to make sure that people didn't write bad code that was not performant. So I got involved in code reviews, so I made sure, for example, if we had a very large data set that was essentially loaded in memory, I tried to make sure that they used an array list instead of a linked list, right? A linked list is good for certain types of operations where you have to do insertions into a middle of a list, but an array list, as you know, it doesn't matter which programming language you work in, right, whether it's JavaScript, Python, or Java, an array list is faster for doing indexed lookups, right? It's O of n, or O of 1, whereas if you use a linked list, doing a lookup against a linked list is O of n. So it's many orders of magnitude slower. So that's the kind of things I looked for when I was doing code reviews, because that's what I was responsible for as a software architect, to make sure people didn't do stupid things. Speaking of stupid things, one of the things I caught in a code review actually was one of the developers had put a system.exit in their code for testing. Does anyone know what system.exit does in a JVM? Right, it basically shuts the JVM down immediately. And I asked this person, I said, are you sure this code is never called? And, oh no, I just use it for testing. That's what they said. So what do you think the chances are that that code was actually called in production? Right, it was very high, because about a week after that release was put into production, I got a call at 3 a.m. on Saturday. The system is down, we can't figure out why it keeps going down. And I told this person to remove it. I said, don't leave this in the code, right? Take it out after you're done testing, don't put it back. And of course, they forgot to do that, and then we quickly were able to figure it out. But anyway, those are the kinds of things that I look for, at least when I was doing code reviews. Now, the other thing is coding guidelines. Nowadays, actually, when we think of coding guidelines, we actually have pretty good coding guidelines across the industry, right? I don't feel like there's a big need for a company or your team to come up with its own coding guidelines. You can probably find a coding guideline or an accepted coding guideline, whether, again, you're in JavaScript or hopefully you're not doing JavaScript anymore, you're doing TypeScript. But if you're in the Java universe or Python or whatever, you can find these off-the-shelf coding guidelines that you can make small adjustments to so that you're not going too far from what everybody else does. And now you might be thinking, well, why would I say that you should just use an off-the-shelf coding guideline handbook, right? The reason is because you're always hiring new people onto your team. And if you have coding guidelines which are so much different than what everybody else uses, now this person has to adjust and train, and of course it takes a long time to do that. So using an off-the-shelf coding guideline, again, if you do a Google search, you'll find loads of them for almost any platform, usually just one or two. And then you can make small adjustments as you need, but typically nowadays you don't need to, because of, we have things like GitHub where everyone publishes their code, and we do a lot more sharing of this kind of knowledge than we used to 10 years ago, 20 years ago, and more, okay? So I talked about performance testing already, so I won't go into that. All right, so this is another big thing that I did as an architect, was technology and library selection, right? So this could be anything from really small things like which logging framework should we use? Should we use SFL for J or log for J or whatever? Or should we use something else, right? So making sure that everyone uses the same library for doing stuff is good, but there's the other part of it which is a little bit more difficult to deal with, because you have smart people on your team, senior developers, principal developers. They come to a conference like this, and they learn about this new tool that everyone's using. And now all of a sudden they're back at your workplace, and they're like, oh, I saw this amazing library that we should be using to do this thing. And you don't want to squash their enthusiasm for helping to improve the system, but you can't just introduce something into especially a large system, or even a small system for that matter, because you don't know what the potential problems might be with it. So instead of just saying no, of course, now you have to sit down with them. You have to understand what this library does. Is it right for the project you're working on? Then you have to maybe run some initial tests, write some code yourself to see what it behaves like, et cetera, right? So the technology selection and especially library selection can be something that's difficult, that you have to get buy-in from your team. But of course, you have to introduce new things, because the one thing about what we do as an industry, as software developers, is that things are always changing, right? So 5 years ago or 10 years ago was Kubernetes and all the cloud stuff. Nowadays it's all about AI. So everything is always changing in our industry. Who knows what's coming after AI, right? So yeah. So one of the other things that I did is we spent a lot of time obsessing about DevOps. This is before DevOps was like a thing, talking about how to do automation to save developers time. So if you're an architect, this is a way to get really easy wins, is how can you automate the crap out of everything to give developers more time back to focus on actually writing code or building software or whatever it might be, okay? And of course, publishing architectural designs and keeping them up to date is a big part of being an architect, and that includes library selection and what your platform looks like, how you deploy things, and all those kinds of different things. All right, so for the last few minutes, let's talk about tools and get into some of the different things around this. And so I don't know if Jonathan is here, but if you're in the Java space, actually Sonar works across a bunch of different things. It's an open source tool. Has anyone heard of Sonar? How many people use Sonar at their workplace? Okay, everyone pretty much uses it, so I won't talk about it. If you're not using it, you should look into it. It's great for using code quality. This is something I used to use for code reviews also. So the output from Sonar would be part of the code review process itself. which was great because it allowed me allowed me as an architect to see what everyone was working on without having to read every line of code and to get a better idea of where problem areas in code might be. There's also a tool called jArchitect, which we'll get into, and we'll talk about Sonar Code Inventory for a few minutes also. Okay, so again, everyone uses Sonar already, so this is just a snapshot of Sonar, but I want to spend a few minutes talking about this, right? Because it's too easy to rely on a tool like Sonar, which uses find bugs and other things underneath the hood to discover things. Now, one of the things for some reason I can't remember the name of the exact tool, but there's a metric called cyclomatic complexity, right? Are you familiar with this? Right. So cyclomatic complexity is something that one of the tools that Sonar runs will help you understand, right? And this is one of the things that I focused on really heavily, is cyclomatic complexity. All right, obviously bugs and other things like that is really, yes, you need to find those things, but especially when you become at a higher level, right? When you're a junior developer, you don't really think of cyclomatic complexity. You're more interested in just cranking out code and making sure the feature works. And of course, I hope you're writing unit tests, right? Does everyone write unit tests in here? I hope, yeah, okay, that's good. Actually, I want to print a shirt out that says, I don't normally code, but when I do code, I don't normally test, but when I do test, I test on production, right? Just wear that around conferences and see if I can trigger anybody. But anyways, we'll talk about testing in just a minute, unit tests specifically, okay? But cyclomatic complexity is one of the things that, especially as a principal or senior developer or as an architect, I looked at, because for me, cyclomatic complexity was an indication of how difficult it was to refactor code. Okay? So if you're not familiar with cyclomatic complexity, what it does is it measures how difficult it is for someone to understand code. Right? So how many code branches do you have? Say you have 100 lines of code, right? That would basically inside of a method you have 100 lines of code. If you have 100 lines of code in a method, that method is probably too long. It's too big, right? So what's the common way that you fix that problem? You break that one method into smaller methods that one method calls, right? So you have smaller methods that are easier to understand. Of course, each method has a name, so you don't have to write extra documentation. That method name will hopefully describe what that line of code does. What those lines of code do, so it's easier for it to understand, and that method will, the main method will call those other methods, so you've reduced your cyclomatic complexity, right? Another thing that introduces extra cyclomatic complexity, for example, is having nested if loops, right? If you have an if block inside of an if block inside of an if block, your cyclomatic complexity is higher because it's harder for us to reason exactly what's going to happen, especially if you have if else. If you do if else and you have if else inside of it, and all those nested inside of it, it makes it more difficult to understand what this code is doing. So that means that the cyclomatic complexity is higher, right? Now, it's impossible to get perfect cyclomatic complexity or very low cyclomatic complexity score, right? There's Jonathan. Hey, Jonathan, you owe me a large bottle of liquor for talking about Sonar, okay? Okay. So Jonathan works as a developer advocate at Sonar. So this is this conference, so I had to include that, right? Anyways, so again, it's impossible to get zero cyclomatic complexity because any code you write will have cyclomatic complexity inside of it. So either as a software developer or as an architect, you want to try to reduce it as much as possible, but there's also a line there where you've reduced it too much, okay? Say, for example, we go back to our method, which has 100 lines of code in it. If we really tried hard, we could probably take those 100 lines and make like 10 methods that call from this larger method, okay? That may not be the right thing to do either, because every time you make a method call, what happens, right? It doesn't matter which language you're in, whether you're in Python or JavaScript or Java, but for example, if you're in Java and you call a method, what happens is that gets put on the stack. Now the stack will execute that method calls another stack, right? That's how you get a big stack, is method calling a method calling a method, right? The problem with that is that when you have a really deep stack, it uses memory and it uses CPU, because every time something goes on the stack and comes off the stack, it uses a little bit of CPU time and a little bit of memory, Okay, again, so I'm looking at this through the lens of a performance engineer, right? So that may not matter to you that much, but again, when you have a really deep stack, that's also an indication of too much cyclomatic complexity. So you have to think about what makes sense in terms of bundling things into a method and trying to reduce that cyclomatic complexity. Another common question is, if you have a bunch of nested if statements, how do you fix that? Right? So that's actually a presentation into itself, right? Some people use ternary statements to keep if blocks really short, or you branch into a method, and that method may contain that if block, right? There's certain ways of tackling cyclomatic complexity that can help with that in terms of managing your code quality, okay? So the second thing I want to talk about, specifically related to this, is it's not shown on this specific sample here. I don't think I have it on this one either, but one of the things that's included, sorry, let me go back. One of the things that's included as part of Sonar, maybe you run it yourself, is something that does unit test coverage, or what we call code coverage, right? So this is, you write unit tests for your code, and you have some kind of tool that measures the amount of code that is tested by your unit tests. Now, let me ask the audience a question here. How many people do unit test coverage and know how much? Okay, so let me ask you here, right? What percentage of your code is covered by unit tests? What's your unit test coverage? 80%. That's pretty good. Anybody else? You're on the same team. Okay, so never mind. Somebody over here? 80%? Okay, that's not bad. Anybody do higher than 80%? 95, holy shit, do you spend all your time writing unit tests? Okay, yeah, he said yes, so. All right, so, and I'm glad that we have like these two kind of spectrums. So one person is 95, and there are probably people in here who do like maybe 60 or 70% unit test coverage, maybe less, right? Now the question might be, again, we're talking about code quality, right? And unit test coverage, unit tests in general help improve code quality. Everyone agrees on that, right? That's an industry kind of standard that unit tests help increase code quality because your code is tested, right? But there are two different things here in terms of code quality, and unit test coverage, and unit tests in general, is that just having coverage for a unit test, having unit tests get code coverage doesn't necessarily mean that that the test you're writing is good, right? Because I can just write a test that says, go and exercise this code, and just give it what we call the happy path, that we know that this is going to work, right? So that's probably how you get to 95, is you probably look at all the different paths, right? You say, now instead of putting it in a number between 1 and 100, right? Like let's say on your web UI, you have a slider between 0 and 100. So you just test between 0 and 100. Well, what happens if something goes wrong in the UI, or there's some bad data, and the number that goes into your test is not between 0 and 100, which is what your unit test is testing for, and you give it a negative number, or you give it a number like 5 million, right? How does that affect your code, right? So these are some of the things that you have to think about. So it's not just about unit test coverage. You actually have to write good, you actually have to think about the test and write tests that make sense within the context of the code or the business logic that you're writing. Now, a question that's common here is, well, how do you figure that out? Unfortunately, there's no good way to figure that out right now, and even some of the AI tools that do testing, they're not quite there yet in helping you write unit tests, because one of the things that's coming up quite a bit right now is that you can get these tools which will write unit tests for you. Yes, amazing. Now I don't have to spend my life writing unit tests, right? Sounds great that you get the AI to write unit tests for you, but the problem with these tools is that they don't write contextually specific unit tests, right? Yes, they have access to your code, but are they writing unit tests that actually make sense with the business logic that's in your code? The answer is usually no. Will that improve over time? Probably, but who knows, right? Actually, that's a good question. How many people are actively using AI Assistant to help them write code today? Okay. So for those of you who didn't raise your hand, if you want to have a job 2 years from now, it's probably a good time to start learning that stuff, right? And I'm not completely bought in. I know the last presentation was on AI, and this one is not. But one of the things that's happening already is that people who are looking for new developers are insisting that those new developers when I say new developers, people who are applying for, it could be any level of developers, junior, mid, or senior, or whatever. They want, one of the things that the criteria, hiring criteria is, that person knows how to use AI to help them code. Okay, so this is something that's coming. If you're not doing it already, you need to at least learn some basic coding assistant stuff. I'm not talking about vibe coding either. Does everyone know what vibe coding is? Okay, yeah, okay. So vibe coding is basically say, build me an app that's like Amazon.com, and it builds it for you. Yeah, that shit doesn't work, okay? Don't worry about it. We're at least probably 50 years away from that, thank God, okay? You can tweet that if you want, or X, put on X. But anyways, the other thing about unit test, and this goes back to code coverage, is that the sweet spot typically for having good code coverage for using your unit test is about 80% actually. If you look at all the studies that have been done out there, and there's some scientific studies that have come out of some universities, they say between about 70 and 80% is about the right level. Because once you get up to 95%, like this gentleman here, what happens is you're not getting any value. The word that we use in English is called diminishing returns. So basically, when you hit about 70%, you're getting the most value out of those unit tests. And the more time you spend on it, that time is not returned to you as much, right? You don't get as much benefit once you hit about 70, 80%. You get less benefit out of it, okay? So again, the software quality, code architect, as an architect, this is some of the things that I looked out for. So I aimed, because we had a huge project, for about 60 to 70%, but this is a long time ago, about 10, 15 years ago on this specific project, okay? All right, so let's talk about a couple more tools. This is a Java-specific tool called jArchitect. This is good for if you're a software architect or a principal engineer or higher-level engineer where you have a lot of code or multiple, especially if you're working in a monolith type of environment. You can see the diagram here on the bottom right gives you a kind of almost like a mind map of all the things. What I did is, this is from just an app server, but I want to use something complicated, right? But it gives you kind of a higher level view of all this kind of stuff, okay? So the last thing I want to talk about is, this is more for Java developers. We don't have anything for JavaScript or Python, but we have a great tool called Code Inventory, which what it does is it tells you which code you're running in production all the way down to the method level. And the important part of there is in production. So what you can do is you can run this for like a day or a week against your code base. Again, you can run it in a test environment, but because it's very, very low overhead, we recommend people run this on production. You run this on production for a day or a week, and then it gives you some kind of output like this, and you can see what code is actually being executed. This is from my colleague, Garrett Grunwald. He wrote a nice UI for it. There's also a web-based UI. This is written in JavaFX. But if you look here, you can see that, again, this is more for Java people. It goes from the jar level down to the class level, down to the method level. So it will also tell you something like, you're not using anything from this jar file at all. Right? Because a lot of people, what you do is you import something like, let's say you're using Spring Boot again, for Java devs, and it pulls in all these dependencies, and you're not using some of these dependencies. What should you do with that? You should get rid of it because you don't need it. Similarly, at the code level, if you're not running some code, and this is especially useful for, not just for older applications, but for newer applications, because as we know, software evolves over time. It doesn't stay static, right? You don't just write software once and forget about it. You actually write software and then you keep adding to it, you make changes, or you upgrade it to the latest version of Spring Boot, or you upgrade to the latest version of Java, or whatever. So this will help you find the parts of code all the way down to the method level that you're not running, and then what do you do with that code? You go and delete it. Because the less code that you have in your code base, the easier it is to maintain, right? And this is especially important as you go from an older version of Java. Say you're on Java 9 or 11 or 17. There's a new version of Java coming out. Well, the current LTS version of Java is 21. 25 is coming out soon. So you're probably going to be getting ready to go to 25. So if you could get rid of all this code that you're not using, it makes the amount of time and risk involved for migrating that code much, much less, okay? And also, like if you're going from Spring Boot 2.7 to 3.4, which requires you to be at least Java 17, again, you have all this migration you need to do, and a lot of this is is manual, so it can be super helpful for that. And again, if you're in the Java universe, this also integrates with something called Open Rewrite. How many people have heard of Open Rewrite? Okay, so this integrates really nicely with Open Rewrite. You run this on production for a while, you feed it into Open Rewrite, and then Open Rewrite, we have a recipe for Open Rewrite which will help you deprecate that code safely over time. Right? It's incredible, it saves so much time, and you might be thinking, how much of my code is actually not being run in production, right? Well, you're probably thinking like, oh, maybe 5 or 10%, right? We're really good at this. We're really good at making sure that we get, we write modern code and we get rid of old code and stuff like that. With some of the customers that we run this against, these are huge customers we heard that you've probably heard of. I can't tell you who they are. Actually, Netflix is a good example. They're one of our customers. They ran this across, I think, 10 different projects, and they found at least a third of their code was never run in production, right? Another customer we ran this with, they ran it across 100 different applications. They found that almost 40% of their code was never actually executed in production. And they ran it for 3 weeks in production. So there you go. Anyways, let's slide there. There's some other tools here. I talked about the AI tools for generation of unit tests. There's some other performance tools I can talk about, but I'm out of time. If you're doing, one of the tools that I really like for writing simple code and keeping high quality is something called Restate. This is something for doing like long transactions across systems, because everyone is writing like microservices, and maybe you're using like a cloud function over here, but you need everything to be in like one stateful transaction. Restate is a really good tool for, it's basically a low-level framework for doing that, but it's a great tool for building like more complex systems in a simple way and writing it with high code quality. So anyways, I'm over time now, so I'll take questions afterwards up here, but thank you for coming. I hope you enjoyed the session.